These are eggs. This is water.
Okay, so once your egg is fertilized, quite obviously, as you can already see visually on the screen, a lot of changes are initiated in an egg. What you're actually looking at is the development of a medaka. That's right, ricefish. So, the egg envelope. This is the most relevant thing to do with hard water and us as hobbyists because we could see it. So, the egg envelope. It's known as the extracellular matrix. A lot of people refer to it as the zona pellucida, the vitelline envelope, or the chorion layer. Now, what that does is it gains in thickness concomitant or in relation to the oocyte. All right, an oocyte is the cell in an ovary pre-meiotic division. And pre-meiotic division is where a cell divides. It divides itself in order to reduce the number of chromosomes by 50%. Okay, so it only has half the chromosomes. What? Why would you do that? So, with only half of the chromosomes that it needs, it is then able to accept the other half of the chromosomes that it needs from the other parent. As a result, the correct number of chromosomes are gained, and it becomes a diploid cell. So, it is a little bit more complicated than that, but essentially you have a diploid cell, which is a cell with chromosomes from both parents. Meiosis happens, and then you end up with four, what they call them, daughter haploid cells, where they only have chromosomes from one parent. Then there's like the prophase and the metaphase, but that all happens before the egg is generally fertilized. My brain is nodding. The thickening of the ECM, the chorion layer. As it grows, it's surrounded by more and more follicle cells. The ECM itself, interestingly enough, does contain, but only a few of the same proteins that mammalian eggs have, which are ZP1, 2, 3, and 4, I think. The guys that you're looking at there, the medakas, they have three major proteins just in the chorion layer, the ECM. And these are gene encoded. So the genetics are not only inside it, they make up the actual chorion layer, the ECM. Now, these glycoproteins in medakas are not only present in the ovarian oocytes of mature females, but also in the liver. Who knew? Who knew? I mean, maybe you knew, but yeah, the liver playing a part in egg production. Wow. It's like wormhole. So anyway, the ECM is actually responsible for a lot more than just what you initially think, protecting it from harms or physical harm, or maybe germs. So it's also responsible for attracting the spermatozoa, regulating the mineral exchange in and out of the egg to get the embryo exactly what it needs, and then also physical harm and germs. So once the sperm is allowed through the ECM, it's finally getting there to be fertilized. The ECM undergoes the cortical reaction of fertilization. Now, what that is the cortical granules release transglutaminase, and what that is to harden the ECM. Like, you know how a chicken egg is fertilized externally, and that is because when they're exposed to air, they go through the same thing. Once they're fertilized, both they harden up. Before that, they're pretty soft. Same with these guys. So with the cortical reaction of fertilization, the transglutaminase hardens the ECM, and that is designed to happen to prevent any more sperm entering. That's what you call polyspermy. And that then results, if that happens, in the zygote having too many chromosomes. Just quickly, a zygote is the cell that is formed when a sperm fertilizes the haploid cell inside the egg, and then it has chromosomes from both parents, and it is returned to a diploid status because it has both sets of chromosomes from different parents. So anyway, the hardening is a result of the links between the Z proteins. Okay, that's what happens. They're affected by the transglutaminase and the alveoline, however you want to say it. And then that hardens the chorion. The chorion in its hard state is actually destroyed by enzymes that are inside the egg later on. So they're just sitting there waiting to make a mess of this chorion layer that thinks it's so hard. There's a couple of enzymes. One is called HCE and the other one is called LCE. Now the HCE starts the attack. He's the Royal Marines. He's in first, boots on the ground, and his job is to expand the hardened ECM or chorion layer. What that does is on a very, very, very small scale, you're not going to see it, is it breaks the links between the proteins. It fractures it, creates weaknesses by swelling the egg just ever so slightly. And then the LCE, the army, they're allowed in then, and what they do is they literally dissolve this hardened chorion layer. And then that then allows your tiny little fry to escape his otherwise prison, which I think is absolutely incredible. So now you can see that the ECM or the chorion layer or the V, whatever you want to call it, is critical in all stages of embryo development. Not just protecting it and it's just sitting there holding it and the embryo's doing its thing. So the elements of hard water that make it hard, right? Primarily magnesium and calcium. Now, magnesium seems to have very, very little effect in any way. So calcium is really where it lies. Now, calcification can stop the transfer of minerals in and out because it forms a little layer on it. It's attaching to areas that need to be taken up by other things. It can harden the ECM, as we call calcification, but it can do it so much that the HCE and the LCE, the enzymes later, can't do their job. Now that means you can have a fully functioning fry trapped inside an egg. Terrifying, right? Luckily, they don't really know much about it, or we hope not anyway. So yes, calcification you could do everything right, but if your egg is calcified, that little baby isn't going to get out. However, it can stop the transfer of minerals, so it may not even develop properly, but it can also affect the oxygen in and out. Now, low oxygen affects embryo development at all stages of development, but is more dramatic. The effects are amplified later on. So if you've got an embryo that is receiving all the oxygen that it requires early on, it's going to form at a certain rate. When it's larger, more things are happening, as you see on the screen, and it needs more oxygen. You then start restricting that, it has a much more detrimental effect than if it was just slightly less than it needed all the way through. Because if it is slightly less than it needs all the way through, the embryos can still develop to be perfectly healthy individuals, just they do it slower. And well, obviously there is always the option that the calcification is so complete that no oxygen is available, and that of course is fatal. So too much calcium can do all of that, cause all of those problems, and it can also affect eggs by osmolality. So too much calcium, too much hardness can affect the osmotic pressure between essentially your tank water, the water outside of the chorion layer, and the fluids inside. Now, if you watched our video back on how airlift pumps work, so how your sponge filter works, that sort of stuff, works on density. And the important thing there, what we can learn is that different pressures, whether it's air or water, they always want to equalize. So high pressure wants to go to the low pressure. So this can happen both ways. If the water outside is too hard for the soft water egg, the zebra pleco egg, it can actually, the osmotic pressure can force the egg to be smaller. It's under pressure, which not only makes it harder for the embryo to actually develop, but it will develop slower and smaller. In the reverse, say you were trying to hatch, I don't know, African cichlid eggs in RO water, very soft water, the exact opposite happens. The egg will actually swell because the pressure inside the choria layer is trying to escape to equalize with the lower pressure outside the choria layer. This can happen to such an effect that the eggs become buoyant. Now, that is a lot more detrimental, it's a lot more fatal to the egg than it is the other way around.
So clearly it's not a case of we need none or we need all the calcium we can get. What it really is about is trying to match the hardness of the water to what the biology of that fish is expecting. Hope you found a reason to smile today. I'll see you in the next one.